All right, so today we're going to be learning about various exponent rules. You're going to refer back to this chart probably at least for day 1 and day 2, if not further on in the chapter. All right, so the product rule involves multiplying where you have the same base. So if you notice, our bases are b, and our exponents are the m and the n. So we're going to keep the base the same, keep it as b, but you just add the exponents together. So m plus n is our new exponent. For a power to a power, you have b to the m all raised to the n. So in this case, you keep your base as b and you multiply your m and n. The power of a product means when you have two things that are being multiplied and all of it's being raised to the m power, then you just distribute a to the m and b to the m. And then this is still a multiplication problem, so it stays as is. If we're going too fast for you to write this stuff down, then just pause the video and come back to the video when you're ready to continue. All right, quotient means to divide. So if we have division, or in other words, a fraction, you keep the base the same and you just subtract your exponent, m minus n. Negative exponents, typically you'll see a negative exponent in the numerator and you move it to the denominator, but you can also see it in the denominator and move it to the numerator. So for an example, if you saw 3 to the negative second, what that means is the same as moving the 3 squared to the bottom. Notice it's now a positive 2, and so that's 1 over 3 squared, and 3 squared is really 9. If you want to see what that looks like on your calculator, so 3 to the negative second, we don't want to leave our answer like this. We would change it to a fraction, and it's 1/9. Right, because decimals don't really make sense for the problems in this chapter. All right, power of a quotient means if you've got a fraction and that whole fraction is being raised to a particular power, then you can distribute that exponent to anything in the fraction. So if it's a over b, then it's a to the m over b to the m. A and b stayed in the same spot. All we did was we applied the exponent to it. All right, the zero power rule is actually the easiest rule that we have, and anything to the 0 power is 1. So I wrote out 3x squared y over z to the 4th. If I have all of that raised to the 0 power, that whole expression becomes 1. All right, and then a reciprocal rule is if we have a negative exponent, basically it's the same thing as flipping the original fraction and making it a positive exponent. But the reason why that works is if we have a to the negative m, right, we can write that there, b to the negative m, we write it there, and then we would follow our negative exponent rule, which is up here. So if you see anything in the numerator, you move it to the denominator, and it becomes a positive exponent. If you see anything in the denominator, it moves to the numerator, and that changes to a positive exponent. And then this is equivalent to that. All right, so we're going to do the problems on the back, and we're going to refer back to this chart. So if you look at problem number 1, we're multiplying, just like in the product rule. So I would keep my base the same, x and x, and I would add my exponents. So this is equal to x to the 9th, because 5 plus 4 is 9. Now another way of writing this out is x to the 5th times x to the 4th, and then count up how many x's you have. Well, you have 5 here and 4 there, so total you have 9 and x to the 9th. So on number 2, we're going to look at our coefficients, and I'm going to multiply my coefficients. So I've got 2 times 1. And then I'm going to look at my bases. My x's are the same, so I keep that, and I add 3 plus 2. So that's 2x to the 5th. All right, problem number 3 is exactly the same thing. We've got a product. All right, so all these were multiplication. Even though this is a negative exponent, we can still do the problem the same way. So I say it's x to the negative 5 plus 11. How much is negative 5 plus 11? Well, that's x to the 6th. All right, so all 3 of these first problems follow the product rule. All right, problem number 4 and 5 will also follow the product rule. Even though they don't look like they're being multiplied, if we have no symbol in between, you can assume that this is a multiplication problem. All right, so you just want to multiply your like terms. All right, so here's my product rule so you could see. Keep your coefficients, right? -2 times -3, we're going to multiply those. And if you multiply, you get 6. And then if you look at your m's, we've got m times m squared. Now it's really just m to the first. Okay, so that 7 that you see there is only applied to the n. So if I add 1 plus 2, I get m to the third. And then I look at my n's, so that's a different base. So I have n to the 7th and n to the 1st. How many n's total? Well, I have n to the 8th. Okay, so overall I have 6. -2 times -3 was 6. 1 plus 2 gave me 3, and 7 plus 1 gave me 8. All right, same thing for this problem. So multiply my coefficients. So I have 3 times -1, that's -3. And then I'm only looking at my like terms. So I have a to the first, that's a squared. B, I have b to the first, that's the only thing I have. And you don't really have to put b to the first because that's implied as a 1. And then I have c to the first and c to the 5th, so grand total I have c to the 6th. All right, so that's all for the product rule, problems 1 through 5. When I get to number 6, now I've got a power to another power. So you have one base. Everything is being raised to a particular power. And you can even refer to this as the power of a product. So if you want to look at it as all of these things being raised to a particular power, okay, look at problem 6, and that's what we have. Everything here is being raised to the third power. So that includes our coefficient. I'm going to rewrite this as a -1, 8, x to the 8th, y to the 1st, and z to the 4th, just so we know where there's implied 1s. So we have -1 to the 3rd. We're just going to distribute this to everything. So there's 4 things to distribute it to. All right, but once you look at each individually, now it's just referring to our power to a power rule. So if I have an exponent already there, I'm going to multiply my exponents. Okay, so I have -1 to the 3rd power, and I have x to the 8 times 3, and I have y to the 1 times 3, and I have z to the 4 times 3. So now you just have to simplify each one. -1 cubed is -1, x to the 24th, y to the 3rd, and z to the 12th. And you don't need to really have that 1 there, so you can just leave that off if you'd like. All right, if you want to go through this part on your calculator, -1 to the 3rd power, that's -1. All right, so problems 7, 8, and 9 are essentially following the same 2 rules. If we already have a power there, we're going to multiply our exponents. If we have a big set of parentheses, we're going to distribute that exponent to everything in the parentheses. All right, so we're first going to distribute this 5 to the x and the y. All right, here there's nothing to distribute, so I'm just going to copy this down. But now we're just multiplying, so it's pretty much like problem number 4. Look for your same terms. I have the same base x, and I'm going to add my exponents. So 5 plus 6 gives me 11, and 5 plus 3 gives me 8. So I have x to the 11th, y to the 8th. For problem number 8, I'm distributing my 4 to everything. So I have a to the 4th, b to the 3 times 4, and c to the 10 times 4. If you want to write in this 1 here, you could call this a to the 1 times 4. So this is a to the 4th, b to the 12th, and c to the 40th. All right, and final problem. We have a set of parentheses with an exponent on the outside. So that means that the 5 has to be squared, and the y to the 6th also has to be squared. So then you multiply your exponents. So 5 squared, how much is that? So let's think about that. What does it mean to do 5 squared? Well, 5 times 5 is 25. A lot of people will put 10, and that's just 5 times 2. That is not what we want. We want to do 5 times 5. So make sure that you're doing 5 squared. That's 25, and y to the 12th. When you come to class tomorrow, you should be able to do any of these problems on your own. And if you get stuck, you can always refer back to this chart.